The F-22 Raptor has been flying since 2005. In over 20 years, no other nation has built anything that matches it. China and Russia have both tried. Both nations have produced stealth fighter prototypes that look similar on the surface, but looking like an F-22 and performing like one are two completely different things. The United States spent $67 billion developing the single aircraft. And then, Congress passed a law making it illegal to sell even one of them to any foreign government. The Raptor was built to be the best fighter jet on Earth, and the barriers to copying it go far deeper than the price tag alone. If you subscribe to this channel, every video breaks down the real engineering behind American military machines. That way you stay ahead of the surface-level coverage you see everywhere else. The first barrier is the stealth coating. Every F-22 Raptor is covered in radar-absorbent material that turns the aircraft nearly invisible to enemy radar systems. This coating is not paint. It is a layered composite material applied with extreme precision across every panel, joint, and seam on the airframe. The material absorbs incoming radar waves instead of bouncing them back to the detector. On a conventional fighter jet, radar waves reflect off flat metal surfaces and return a clear signal. The F-22 scatters and absorbs those waves so effectively that its radar cross-section is roughly the size of a steel marble, a full-size fighter jet with a radar signature smaller than a ball bearing. That is the level of engineering involved. But the coating is fragile. Sand erodes it during low-altitude desert flight. Humidity degrades it in tropical operating zones. Thermal stress from sustained supersonic flight causes it to crack and peel across the airframe panels. The Air Force spends roughly 30 hours of maintenance for every single hour the F-22 flies. About 1/3 of that maintenance time goes directly to inspecting and repairing the stealth coating on the fighter jet surface. Technicians at military bases walk the entire aircraft body with specialized instruments, checking every square inch for coating damage that could increase the radar signature. Each flight hour costs approximately $85,000. The materials themselves are classified, and the exact chemical formulas remain some of the most closely guarded secrets in the American defense industry. Even allied nations with advanced aerospace programs and decades of fighter jet experience do not have access to these coatings. The second barrier is the AIR frame itself. The F-22 is built from advanced carbon fiber composites and titanium alloys, machined to tolerances measured in thousandths of an inch. The airframe shape was designed using decades of computational modeling at Lockheed Martin's Skunk Works facility in Palmdale, California. Every angle on the aircraft body is calculated to deflect radar energy away from the source. The leading edges of the wings, the tail fins, and even the weapon bay doors are all aligned at matching angles, so radar waves scatter in predictable directions, away from the enemy detector. The engine inlets use a serpentine design that completely hides the turbofan blades from radar. If you shine a radar beam straight into the intake of this fighter jet, the signal bounces off curved internal walls and never makes it back out. That serpentine geometry requires manufacturing precision that very few factories on Earth can achieve. Even a tiny misalignment in the inlet walls would create a radar reflection that defeats the entire stealth design of the aircraft. The engines themselves add another layer of difficulty. The F-22 uses two Pratt & Whitney F-119 turbofan engines. These are the only production fighter engines in the world capable of sustained supersonic flight without afterburner, a capability called Super Cruise. The Raptor can fly above Mach 1.5 without lighting its afterburners, which means it burns less fuel and produces a smaller heat signature than any other fighter at supersonic speed. Building a turbofan engine that can sustain Super Cruise requires metallurgy and blade design that took American engineers decades to develop. The turbine blades operate at temperatures that would melt conventional metals. They survive because of single-crystal nickel superalloy construction and advanced thermal barrier coatings. Replicating those blades requires equipment and expertise that exist in only a handful of facilities worldwide. Then there is the cost barrier, which may be the tallest wall of all. The F-22 program originally planned for 381 aircraft to spread the enormous development costs across a large fleet. Budget pressure and the end of the Cold War cut that number to just 187 operational fighter jets. With $67 billion in development costs spread across fewer airframes, the final price reached roughly $334 million per aircraft. At that cost, even wealthy nations cannot afford to build a competing program from scratch. China and Russia have both spent billions on their own fifth-generation stealth fighter programs. The Chinese J-20 and the Russian Su-57 both claim stealth capabilities, but neither aircraft has demonstrated performance data comparable to the F-22 in independent testing. Their radar cross-sections, supercruisability, and sensor fusion remain unproven against American benchmarks. Congress locked down the final barrier in 1998. The Obey Amendment, included in annual defense spending bills, prohibits the use of any federal funds to approve or license the export of the F-22 to any foreign government. In 2006, Congress voted again to uphold the ban permanently. This restriction has never been lifted, not even once. Close allies like Japan, Australia, and the United Kingdom have all requested access and been denied. Japan even offered to co-produce components for the aircraft, and the answer was still no. The intent behind the ban is clear. The stealth technology, manufacturing techniques, and classified sensor systems inside the Raptor are considered too sensitive to risk exposure through any foreign sale. If an allied nation bought the F-22 and one was captured, shot down, or crashed in contested territory, decades of classified American research could fall into enemy hands. A single recovered airframe could give a rival nation a blueprint for defeating the very stealth technology that protects American fighter pilots. The F-22 Raptor sits alone at the top of air combat capability because the United States built barriers at every level, classified coatings that no other nation can reproduce, manufacturing precision that requires decades of specialized tooling, engines that operate at the absolute edge of material science, and a legal wall that prevents any shortcut through purchase or license. The Raptor was not just designed to win fights, it was designed to be impossible to replicate. If this video gave you a deeper understanding of American military engineering, subscribe to Steel Doctrine. Your subscription keeps this channel running, and we will keep delivering the breakdowns you came here for.